Ed, here I am collecting hydrogen gas. We've got some zinc metal, your school has it, and some 1 molar hydrochloric acid, your school has it. Feels like you got maybe 80 to 100 milliliters left. And reacting them in a test tube, zinc plus hydrochloric acid makes zinc chloride, which is just dissolving in water, and hydrogen gas. Hydrogen gas is lighter than air, so it's supposed to go into that test tube, because this test tube is arranged just above the source test tube. There's a little gap here in between the two test tubes to allow ordinary air to leave. So the hydrogen gas is supposed to displace the ordinary air. This is not my first attempt here today, so I'm not sure what is going on. I seem to be leaking hydrogen gas somehow. I mean, of course, there's some is going to leak here, but I want most of the hydrogen gas to get into my test tube. I think I'm leaking hydrogen gas out of the top test tube. But anyways, I'll let this hydrogen gas continue to form here. Are we still fizzing in there? Yeah, we're still fizzing in there. So I'll just let that go for a while longer while I show you your oxygen gas. So you've got a lot of hydrogen peroxide located on the top shelf over there. And I'm going to put some in this Erlenmeyer flask. The Erlenmeyer flask is useful for this because the neck is, the mouth is smaller than the base. So that makes it easy to hold on to the oxygen gas as it forms here. Now, yeast is a really good catalyst. You've got yeast in here. Yeast makes catalase, an enzyme that catalyzes the decomposition of hydrogen peroxide. Now, manganese dioxide is also a good catalyst, manganese 4 oxide, or MnO2. Now, you don't have that, but you do have some very old potassium permanganate. As potassium permanganate gets old, I'm not sure if it oxidizes to form manganese 4 oxide or reduces. It reduces. It gets reduced to form manganese 4 oxide. So you have in this box some specks of manganese 4 oxide, which is a great catalyst. So if you just use this trash, just throw that in there, boom, that brown stuff is manganese 4 oxide. And those bubbles are oxygen gas. How do we know it's oxygen gas? Haha, this is what you want your kids to do, right? You could do this with yeast, of course. I mean, manganese 4 oxide and potassium permanganate are both, these are both oxidizing agents, so it's probably better to do it with yeast. Let me just prop this up here for you. It's probably better to do it with yeast for safety and for environmental responsibility. You have a box of wooden coffee stirrers in your drawer. The same drawer that contains your thermometers and your glass stirring rods. So you also have a box of matches in the adjacent drawer. So I'm just going to light this on fire, and then I'm going to blow out the fire so that this is a glowing splint. Okay, that's not, oh, it is glowing. Okay, so you see that it comes back to the flame. Can you see, am I showing this? Sorry, I'm not really looking. All right, so I have to hold the phone. All right, so you can see this comes back, that the flame comes back to life. This is a positive test for oxygen gas. You can do this. It's fun to have a little contest, you know. How many times can you do this? It's so awesome, right? It's like Harry Potter. Lumos! Boom! Nice. No flame, and then flame. Like a little pop, you know, the little explosion. No, no flame, and then flame. Oh, I love it. So that's my suggestion for you and your kids to test for oxygen gas. Now, I want to show you my suggestion for carbon dioxide gas, which is very similar. So I've got in here a flask from your cabinet, which has baking soda, also from your cabinet. It's in the low hazard cabinet just above the sink. I've got in here some 1 molar hydrochloric acid from your hazardous cabinet, which is locked. I got the key from Jim. The key is on his couch. Now, let me pour this in here so that we can get some carbon dioxide gas. All right. Nice carbon dioxide gas there. Nice carbon dioxide gas. And now, the traditional test for carbon dioxide gas is to light this on fire and put it in here and see that the fire goes out. All right. So let me do for you that traditional test. But there's another alternative way to test this that I think is a little more interesting. So I'd like to do that for you also here. So this is nice and flamey. And can you see what I'm doing here? Let me hold the phone so I can verify that you can see what I'm doing. All right, now I'm going to put this in here and just fire goes out. Sorry, guys. It's interdiction zone. Not allowed to have a fire there. All right, so that's carbon dioxide gas. But see, the really cool thing about carbon dioxide is that it is 44 grams per mole, heavier than air. Air is about 30 grams per mole. This is 44 grams per mole. So that means I should be able to pour carbon dioxide. So I'd like to do that for you, please. I want to light a candle here, and then I want to guide the carbon dioxide. I'm going to pour the carbon dioxide and guide it onto the candle to put out the flame. So I'm going to put a little flame in there. Nice little flame there. Nice. Do you see what I did? Okay, good. Now I'm going to use this paper that I pulled off of your wall. It's somebody's subplan from last month. And I'm going to pour carbon dioxide on the flame. Can you see that the flame is on? I don't think you could see that the flame is on. I need to arrange the phone so that you can see that the flame is on. Okay, now you can see that the flame is on. I'm going to turn off the light, one of these lights, so it's easier to see that the flame is on. Okay, good. Now I'm going to take this flask and I'm going to use the paper to pour. I'm going to pour carbon dioxide gas onto. Well, you can't see what I'm doing, so I'm going to turn on the light after all. Okay. So you see the flame still? Good. So I'm going to pour carbon dioxide gas onto the flame. You will see no liquid there. Did you see that? Flame is gone, but there's no liquid. What I was doing was I was pouring carbon dioxide gas like this while holding the paper to guide the gas onto the flame. Now, let me show you that that does not work with any gas. It only works with something heavier than air that is not compatible with combustion. So I have, of course, my oxygen gas, right? I still have the oxygen gas. Now, because I have thrown the glowing splint in here a couple of times, there is some carbon dioxide gas in here, but it's still bubbling oxygen gas. So I think it's mostly oxygen gas. Let me see what happens if I try this with oxygen gas. So I will have to relight the flame, of course. Relight the candle. Light my candle. Come on, baby, light my. Oops. Put that. The candle was ironically put out by its own fuel. All right, here we go. Can I light some of that? Okay, wax. All right, so now I'm going to see what happens if I pour some oxygen gas. No liquid, just the gas. Pour the gas. I'm pouring the gas. I'm pouring. Oops. Okay, there goes some liquid. So yeah. So I was pouring gas so much so that some liquid even fell out, and that didn't do anything to the flame. The flame didn't go out. So it only works with carbon dioxide gas. And let me pour some carbon dioxide gas to put out that flame. No liquid, just some carbon dioxide gas. Carbon dioxide gas. Psh. Oops. Oops, oops, oops. Pour some carbon dioxide gas. Oops, oops. I better use ordinary methods for that. Okay. Sorry about that. I guess I ran out of carbon dioxide gas in here. The limiting reactant was the acid, not the baking soda. But I think you get the idea there. Should have had some more carbon dioxide gas in there. I think that. Oh yeah. So the next thing is I want to see if I have collected enough hydrogen gas here to ignite. Let me pause the video. So here I've got a glowing splint, and I'm going to see if I can ignite hydrogen gas here with this glowing splint. Just increase the gap, and splint is still glowing. No love. No hydrogen gas. Okay, so I'm going to have to try that again, and I'll pause the video, try this again, and see if I can ignite the hydrogen gas for you. It's supposed to make a sound. So I've set this up again. I've just decanted off the water, and I've added some more 1 molar hydrochloric acid. The limiting reactant here is the acid, as you could see, because this is the same zinc that I had in here before. I've increased the size of this gap so that I could encourage the hydrogen gas to go into the test tube up here, rather than bouncing off of the existing air and coming out this way. I think that might have been the problem, perhaps. But I do want to get the alignment right, so that the hydrogen gas actually does get into that upper test tube. Okay, it seems okay. Seems all right. I'm going to try to ignite this again for you. Hope this works. If it doesn't work, I'll pause the video and try it a third time. These unsuccessful attempts kind of serve as a control group. What happens when you put a match? Ah, that's great. So that's the sound that we're looking for. That whistle. That whistle indicates that there was hydrogen gas there. The sound that you did not hear before, that was a control group. That's what happens when you put a lit splint or a glowing splint next to a test tube that does not contain hydrogen gas. Now, the sound, yes, the sound. So it's hydrogen gas, H2, and it reacts with oxygen gas, O2, to make water. So upon ignition, the water tends to condense. And when that happens, the volume of gas in the test tube is very low. And that means the air out here is going to rush in there to fill that void volume. And that rushing creates that whistle sound. So that was oxygen gas, carbon dioxide gas, and hydrogen gas. I need to show you where all your reagents are. Nothing here came from me. This is all from you. It's all stuff that RT owns. Your hydrochloric acid is here. You've also got 6 molar hydrochloric acid, about 50 milliliters of this. This is way too concentrated for what we're doing here. You can dilute this easily. If you have, let's say, 50 milliliters, just get 250 milliliters of bottled water and pour your 50 milliliters of 6 molar in there for a total of 300 milliliters, and that'll make 1 molar hydrochloric acid. 1 molar hydrochloric acid is all you need, as you saw there. You can speed up the reaction by using 2 molar or 3 molar, but it's not really necessary. Look, it's still making hydrogen gas there. Now, where is your hydrogen peroxide? Your hydrogen peroxide lives up here in the upper corner, the back of the room, and that's your oxidizer cabinet. That's also where potassium permanganate lives. If you don't find any old crumbs of potassium permanganate in the box, it's okay to use a fresh crystal of potassium permanganate or a few fresh crystals, because potassium permanganate reacts with hydrogen peroxide on contact to make manganese 4 oxide, MnO2, and that is what you need to catalyze to catalyze the reaction, the decomposition reaction to make oxygen gas. But of course, the safer way to do this is to use yeast. And your yeast is right there. Your sodium bicarbonate is right here. And your zinc. Your zinc is in this cabinet here. If you run out of zinc, you don't have that much. If you run out of zinc, you could also use magnesium for exactly the same effect. The magnesium is a little more expensive than zinc, which is why I prefer to use zinc. Please do not use the powder. So don't use the calcium. Huh? So please don't use the powder. The powder, you have zinc powder up here in the metals, but zinc powder is dangerous stuff. So I don't recommend you use that. If you're the teacher, I mean, you can use it if you like, of course, right? But it's a little dangerous. So what am I trying to say here? So I think that's it. Oh, I need to say one more thing. For your manganese 4 oxide, this is safe to go in the trash. So it's a good idea to wait for the solids to settle, and then you can pour off the liquids. But the solid or just some liquid and most of the solid manganese 4 oxide is safe to go in the trash. And of course, the sodium bicarbonate is soluble in water, so that's safe to go down the drain. And the acid. So there's acid in here. That is not safe to go in the trash, and it is not safe to go down the drain. What you got to do is you got to neutralize the acid, and then you can pour everything down the drain. Now, I had baking soda in here, so I can use the residual baking soda to neutralize the acid. You can hear the fizzing there. So once the acid is neutralized, you can throw the liquid down the drain, but the solids you're going to have to throw into the trash. Alrighty? Oops. Okay, so I'll clean that up for you before I leave. And so those are 3 gases. Now, if you want your students to produce a mystery gas and then test to see what that gas is, what I recommend is Alka-Seltzer. You have some Alka-Seltzer back here. You can have them put that in water, and they can collect a whole bunch of gas and see what gas that is. You could also use a metal. So suppose you use magnesium. You could have the kids do acid and zinc and test to see what gas that is. Or suppose you use zinc. You could have the kids use magnesium and acid and test to see what gas that is. You can ask them for hypotheses. And every time, of course, it's important for them to have a control group. So with the carbon dioxide, I tried to use my oxygen as a control group. You could just have them use an empty flask, just ordinary air as a control group. For the oxygen, I didn't show you a control group for the oxygen, but it's kind of obvious. You just have them do the same experiment with an empty flask, ordinary air, and they will see that it behaves much differently. For the hydrogen gas, my first attempt at collecting hydrogen gas was a failure, and that served as the control group. I mean, nothing happened. And for the carbon dioxide gas, you saw me try to use the oxygen gas as the control group. Thank you, Ed. Oh, one more thing, Ed. I noticed you have a green Post-it note on your laptop about the crime investigation kit. Yeah, that had already been here. It had been under there, but I put it under your laptop for your convenience. That's it right there. Alrighty. Let me know how that goes. If you want more materials like that, we have a little bit more. Thank you. Bye.